Now you should have sound. So this is the other thing when you have a classroom. I just spent a good 3 minutes talking to myself. And that's embarrassing, although Lord knows I've done worse and I'm certain I'll survive. So, yeah, maybe if there was somebody watching before who was a really good lip reader, they will hear all of that. But I assure you, it wasn't of all that much consequence. I did want to mention, though, again, now that I do have sound, probably be good to go back and mention a little bit that I am doing an archive of these on YouTube. So that's the bit.ly link that you'll find. There is a link to a YouTube channel. Again, I put in a plug for my corporate training. And again, as I say, with the current virus situation, I'm available to do online training. If you happen to know of anybody who's interested in that, you can certainly send them my way. I'd be happy to do that. And hi, I'm glad to see you too, from all the way from Spain. So it looks like the European group has arrived at least. That's good. And what else? Again, if you're interested in the Quick Python book, let me know. I do have codes for ebook versions of that. And all of the usual stuff about shells that who cares about, because I want to get on to talking a little bit about iteration. So I guess one other thing I should say, and a couple of people have already said hi, is that to certainly feel free to jump into the chat as things come up. And I will be kind of leaving spaces where I hope people will jump in and either answer questions or offer suggestions, things like that, as we go forward. But what I want to talk about today is iteration. And iteration is the repetition of code and data. It's doing the same thing with a bunch of data in series. So that is one of the things that makes computer programs powerful. Hey, Chuck, glad to see you too. So I want to talk today about the way Python does iteration, and it's referred to as the iteration protocol. And in a second, we'll find out why it's a protocol, which is not something that you normally hear about iteration. And I'll also invoke the name of a friend of mine, a famous Pythonista, Dave Beasley, who coined the phrase iteration is Python's most powerful, useful feature. Just an interesting combination of words. And he said that, for one, in his talk at, I believe it was PyCon Pakistan about 3 years ago. He did something called Iterations of Evolution, the unauthorized biography of the for loop, which is a fascinating talk, as Dave's talks always are. And it also features him playing the Monty Python theme song on his trombone. So I might also add that he gave that one remotely, so even 3 years ago, Dave was way ahead of all of us in terms of doing remote Python content. But yeah, so let's talk a little bit about what I'm talking about in terms of iteration. And it's really dead simple, right? We have something like a list. This one contains 1, 2, 3, 4. And we want to loop over it, unlike what we might have done in the bad old days of C, or what we might have done in the bad old days of Java or other languages like that. And I'm talking, 20 years ago, something like that. We in Python have a particular way of doing this. In other words, we just say for item in a list, print item. And as we all know, that just works. Well, it would work if I've triggered it. There we go. Um, it's kind of impressive how simple that is. There's no machinery there other than the keyword for and the keyword in. So that's what I want to talk about, is how this actually works. So to begin with, as I say, these days most people I think would say that for loops are kind of obvious. I mean, who needs to worry about those? This was not always obvious. So let me get you, this is ancient history. Uh, so this comes from the Python version 1.1 documentation done in 1994. And you can pick other versions, but I dug this out, downloaded the source code. You can still do that. And this is in the documentation. And it's about Python and for loops. And it says the for statement in Python differs a bit from what you may be used to in C or Pascal. Rather than always iterating over an arithmetic progression of numbers like in Pascal, and again, I was teaching Pascal at the time to students. In Pascal, a for loop does just go over a series of integers, or leaving the user completely free in the iteration, test, and step as C. It's also true. I don't want to go into C here, but I will sort of say that in terms of just setting up a for loop in C, there is a form that you use, but what you actually put in there is pretty much can be anything, even totally unrelated to any loop or anything at all. So it's kind of a free-for-all. So rather than either of those choices, Python's for statement iterates over the items of any sequence, e.g. a list or a string, in the order they appear in that sequence. And hi, good to see another person came in. This, like I say, this makes me feel better. When I was talking to myself before I remembered to turn on audio, I was reflecting that this was the difference between teaching in person and teaching virtually. Streaming like this, I never know who's there. So not only do we do this thing going over a sequence in Python, but it works kind of regardless of type. So we can do iteration, a for loop, for example, with keys in a dictionary, with characters in a string, with records in some query results, with lines in a file. Those are all very different things. It really would be hard to imagine that those were all somehow part of the same class or something like that. I mean, okay, I suppose you could force it, but it would really be hard to make, to kind of think of those as all the same thing. What they have in common is that they are a sequence of data, and that's it. So all of this kind of raises some questions, I think. So one question is, with a for loop, all we've got is for, and then a variable name, and in, and then the name of our sequence. How does the for loop, as it loops, how does it know what's next? I mean, if you were doing this the old-fashioned way in C, you'd have an index variable, and you would increment the index every time you went through the loop, and you would know. But how does a Python for loop know what's next? And how does it get away with using so many different types? And kind of the opposite side of that same question, what is it that makes an object work as something you can iterate over? What does it have to have? There must be something. You can't do it with everything. You can't iterate over an integer. So what is it that means we can use an object in a for loop? So those are the things that I want to show you today. Now, I said that this was a protocol and that the word protocol was important. So we're getting to that. iteration has been a protocol since Python 2.2, which is about the time, nearly 20 years ago, that I started using Python. And this also makes iteration a great example of what we mean in Python when we talk about duck typing. You know, anything that walks like a duck, quacks like a duck, we can pretend it's a duck. So it's the same thing. Anything that follows this protocol is something that we can put in a for loop, basically, that we can iterate. And for the iteration protocol, you need two things. You need an iterable object, and we'll find out about that in just a second. And we need an iterator object. And we'll find out about that in a little while. But the good news is that Python usually takes care of that without you having to do anything. So, let me get back here in the right place. So, iterable. Okay, this is from the Python documentation. Like the bolding and formatting is mine. An iterable is an object capable of returning its members one at a time. Okay, examples of iterables include all sequence types like list, string, tuple, and some non-sequence types like a dictionary, file objects, and any user-defined classes, as long as they either have a dunder iter method or they have a dunder get item method that implements sequence semantics. And hang on, we'll talk about that. Iterables can be used in a for loop and in many other places where a sequence is needed, zip, map, etc. When an iterable object is passed as an argument to the built-in function iter, it returns an iterator object. Okay, so one thing is that an iterable needs to return an iterator. Okay, we're going to explore this. The iterator is good for one pass over the set of values. When using iterables, it is not necessary to call iter or deal with iterator objects yourself. The for statement does that automatically for you, creating a temporary unnamed variable to hold the iterator for the duration of the loop. Okay, I promise we're getting sorted to the end of the boring stuff here, and we'll actually see some code in just a second. So, just to be sure we're clear on this, because this is something that surprises people again. An iterable returns its members one at a time. List, string, tuple, or anything with a dunder iter or something with a dunder get item that follows sequence semantics, and we don't need to create the iterator. That's just restating what we just said. And again, an iterable must return an iterator when the iter function is called on it. There are two ways that this can happen. One, it can have a dunder get item. That means it uses the square bracket notation with sequence semantics. That means integer order, like a list where you can get slot 0, slot 1, slot 2, slot 3. That's sequence semantics. Or it will implement a dunder iter method that returns an iterator. And again, we'll talk about that in a little bit. So if we have a list and we want to know, is it an iterable? One thing we can do is we can ask if it has a dunder iter method. And in the case of a list, we'll get true, and that's all we need to know. If it's in the case of, example, a file stream, we can iterate over a file object. It doesn't have a dunder iter method. So, it does have a dunder iter method. I'm sorry, that's a bad example. But if it is something that doesn't have a dunder iter method, then we need to know if it has sequence semantics in its get item. That is, can we call get bracket 0, get bracket 1, etc., and get the things in order. And it's hard to check that programmatically because we need to see what's going on with how it behaves. So this is kind of a case where Python's philosophy of easier to ask forgiveness than permission and just go ahead and try stuff works. You could fool this clause of dunder get item, I suppose, with a cleverly constructed object, but in general, if it uses integers as indexes, it follows the sequence semantics and dunder get item works. Okay, well, I'm glad that wasn't boring, but let's actually do the stuff instead and see. So here I got to make sure that I have my cheat sheet handy because I'm going to do these things kind of live. And rather than having me flounder around forever, if I get it wrong, I'll just look over my cheat sheet. So let's make a test iterable class. So we're going to make one. And this one, it's got very simple-minded requirements because I want to see the process of making the class. But then again, several of you have been here before. You know this is what I do. And this one is going to be a repeater class. And what we're going to do is we're going to give it a value that it will repeat and the number of times that we want it to repeat it. So if I say repeater hello 4, it will be a class that will make an instance of the class that will repeat hello 4 times. And we can put it in a for loop, that instance, and it will then give us hello 4 times. So that's pretty easy. But it's a good way to illustrate what is the bare minimum of stuff we need to make an iterable. And what we're going to do, we're going to use this with the dunder get item method. Okay. So, I mean, in this case, what I'd want to do, first of all, I want to set my parameters. So I need to know what value I'm going to be repeating for future use, obviously. And I need to know how many times to repeat it. So we got that set. Now here is where things get a little bit interesting. Now dunder get item is what gets called when you try to access something using the square brackets on an object. So obviously it's an instance method. We've talked about this before. It's a bound method, so it needs to have self. And it also needs to have the number of the slot that you want to access. So it needs to have an index. Okay, now in general, what happens is we will return something if the index we're looking for is greater than 0, because we're not going to worry about negative slicing in this guy at all, okay? This is not a list. This is just something that we can get by index. So we're going to say that its index has to be greater than 0, or 0 or greater, I'm sorry. Should be greater than or equal to 0 because we start at 0, okay? And it needs to be less than self.limit. Because again, if self.limit is going to be 4, for example, but we're going to start at 0, then to get 4 times, we go 0, 1, 2, 3. We need to stop before we hit the limit. So we're going to do that. Okay. And we can do that. That's fine. If we only do this, we will have an endless loop on our hands if we try to put this in a loop, because we need to handle the case if we get an index that is the limit or larger. What happens if we are too large? If we're using a list and we've got 3 items and we say give me item 100, it says that we have an index error. Okay, and that's exactly what we need to do here. So first of all, I'm getting ahead of myself. We want to return self.value here. So if we're in the limits that we say, we'll return something. Else, we want to do what any other sort of sequence would do if we're trying to call something illegal. And that is, we would raise an index error. Okay, so this gives us I'm sorry, getting going crazy here. There we go. Let's get back on the right track. Okay, so now we've got something where we're basically init stores the value we want to repeat in our limit, and here we're checking to see if it's in a legal range. If so, we return the value that we were going to repeat, or we're going to raise an index error because it's out of bounds. We've either tried to call a -1 or we've tried to call something that's too big. Okay, so we'll run that, and then I'll make sure that I have my syntax right, and there we go. So we've got the class made. Yep, I've made so many mistakes, Chuck, that I'm usually pretty good at catching them just because I have so much practice making mistakes. That would be my answer. So we've got this. So let's sort of try it out. So first of all, I can make a repeat object. And let's just see if it has a dunder-iter method. That's kind of a silly question because we can see up here nowhere have we put in a dunder-iter method. And in fact, that's what we get. It does not have a dunder-iter method. A repeater object has no value? What? I don't even know why it's doing that. I'll repeat hello 4. This is actually throwing an error earlier. Okay. There's no object value. Oh, I think I have a self-value. Let's get this out of the way. Repeat hello 4. Oh, well, now see, you could have stopped me from being silly here. There we go. There. That's fixed. All right. This works. Yep. Okay. So now the question is, does it have a dunder-iter? And you heard all the patterns. So let's see about here. False. It does not have a dunder-iter. That's absolutely right. It's got a dunder-get item and a dunder-init. Not everything gets a dunder-iter, so it's not something you would get inheriting from object. So yeah. But then, does it follow sequence parameters? Well, the only way we can test that is to see, do we get a value when we start at 0? Well, yeah. Do we get a value when we go to spot 3? Yeah. Well, suppose we get a value when we go to spot 4. Nope, that's out of bounds. We said our limit was 4 items, so 0, 1, 2, 3 would be right. So, apparently, we can't guarantee it, but it looks like it. So then the next question is, can I get an iterator from it when I call the iter method, or the iter function on it? Will I get an iterator object? And again, we don't know what iterator objects are yet, but we're getting there. So again, looking at the thing, we don't have anything that has to do with iteration here. So, it's a little bit mysterious here. if we call this iter thing on repeat and we know it doesn't have anything that handles this, should that work? Okay, well, I mean, let's go ahead and just see, because there's a lot of stuff. So in fact, it does. Again, putting aside exactly what an iterator is for the moment, definitely we got one. So that means that this thing up here is an iterable. Okay. Then will it work in a for loop? It's a good question, Chuck. How does it do it? And I'll explain a little bit in a second. It's like yes, because it's Python is kind of the answer. So yeah, so we've seen this thing. Theoretically, this should work in a for loop. Even though you've seen how little is there, there are only, actual code. There are only 6 lines of actual code there. Well, actually, code, there are only 4. 2 of them are just setting variables. So, well, let's see. I mean, the only way to find out for sure is to try it. And it works perfectly. Okay, so what happened? And this gets at your question, Chuck. Behind the scenes in that for loop, the fact that it's a for loop caused iter to be called on the repeat object and to get a nameless, invisible iterator object. It's just created by the scenes, but it never gets a name. It's just handled behind the scenes. So, and then that iterator object will start getting things from our iterable, starting at index 0, 1, 2, 3, until, and this is the key, until it gets an index error. When it gets an index error, that's the signal to stop. And each time that we do this, each time that we make this for loop, we will create a new iterator that will be used for that cycle of iteration and then thrown away. So yeah, I agree. It's like when you dig into this, it's really got a whole bunch of neat stuff going on that nobody would think of for just lowly iteration. But it's kind of all there. So it's just really sort of interesting. A couple of things that are particularly interesting here. One of them is the fact that raising an exception is a key part of the mechanism. If the iterable doesn't raise the exception, the loop won't end. And so people who are not used to Python and the way Python uses exceptions are quite often shocked, I tell you, that Python uses exceptions to handle flow control, to handle the way that the program actually behaves routinely. Coming to the end of the loop isn't some disastrous error. We expect it, and we're counting on the exception to help us know when to stop iterating. So I find that to be very cool indeed. Okay, but you've seen how I made this. So my next question is, do you think it will work with the list comprehension? And to circle back, it needs to be specifically, in that circumstance, it needs to specifically be an index error. Okay, if you were to raise a value error or a key not found error or anything like that, that would not actually function as a signal to that the iterable is done and you need to end the iteration. So it's only that one. So yeah. Okay, so then list comprehension, will it work? It should work, because a list comprehension is really just kind of a really almost a syntactic sugar for this particular pattern. It's meant to do the same thing as this particular pattern. It would be very surprising if it didn't work. So we'll do it, and we get hello, 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 hello. It's exactly the same thing. It works as you would expect. So that is how easy it is to make an iterable. Obviously, you can do all sorts of other stuff. There can all sorts of other in machinery in the object. But the part that would make it iterable comes down to two things. It comes down to being able to follow the sequence semantics of returning the value if the index is in the right range, and that range being a series of integers starting from 0. And the second thing is it needs to raise an index error when it's done, or you'll have an endless loop. So behind the scenes, what the iterator is doing, when we call iter on this really simple iterable, what that is doing is actually setting itself up to start iterating from 0 on the object that you give it and watch for an index error. As long as those things will work, that iter that is created just sort of, okay, can I do 0? Can I do 1, 2, 3, 4? As long as that happens and you either get objects back or you raise an index error, then the iter function can create an iterator out of anything that will do that. So I think this is one of the cool things, is that it's actually really, really, really simple to do this. Okay. Here I've got another one, and I'm kind of up for grabs on this. We have other things to talk about, so that I'm fine with moving on and leaving this as an exercise for the reader. This is what I give when I am teaching this class. When I'm teaching this as a class, is I say, okay, let's make a Fibonacci generator, or a Fibonacci iterator that will just sort of, you tell it how many Fibonacci numbers you want, and you can for loop over it and get the Fibonacci numbers. If you want to do this as an example, say so in the chat. If you think you want to just move on and find out more about iterators right away, we can do that. So it's a pretty fast example. Actually, this should be, see, this is, you need to keep things straight. This is a Fibonacci iterable. Okay. All right. Anybody want to see it? Want to move on? Okay, got the idea of how to make it. That seems to indicate that we're fine moving on. Any other responses? If you download the notebook, my solution is in the notebook anyway, so it's not a big secret. Okay, well, let's go ahead then. Okay. We can also then look at what is an iterator. And an iterator is the thing that actually helps a for loop or any other sort of iteration like that know what's next. Because, as we said before, the iterable doesn't have any way of knowing what item is next. We didn't put that in there. It's just, if you say I want slot 3, it'll give you slot 3. If you say I want slot 1, it'll give you slot 1. But it doesn't know which one you're going to ask for next. And we also saw that the for loop is just for and in. So, you know, it in itself doesn't have any explicit machinery for keeping track of what's next. So all of this is the job of the iterator. This is what they do basically, is keep track of where you are in the process of iteration. So the thing that makes an iterator is that it has a dunder next method. Okay. Python 2 now is officially passed on, so we don't have to worry about Python 2 anymore. For some bizarre-eyed reason, it was next without the underscores in Python 2. I just need to take that out of all of my materials, though, I guess. So it needs a dunder next that will keep track of and return the next item every time that you ask for next. So if you use the built-in function next, or you're in a for loop where that's kind of implicitly done, this is what says, okay, next, 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 passes them along. So to kind of rephrase that, an iterator has a dunder next method and calls to that dunder next method, or using the next built-in function, will give you the items in order, one after another. And it will raise a stop iteration exception when it has no more data. Sorry, I didn't mean to go there. And when it gets done, when you get to the end, it will just keep on raising stop iteration over and over and over again. Okay, one more requirement is that all iterators must have a dunder iter method that will return itself. So if you ask an iterator, what's your iterator? It will say, me. So it has to match that up. And that means that iterators are all also iterables. It gets a little bit circular sounding, I admit, but when you get used to it and experiment with it a bit more, you can start to see how it works. So any place where you could put an iterable, like in a for loop, you can also put an iterator, because iterators are by definition iterables. With one difference. I can iterate over the same loop or the same list as many times as I want, because a list object is iterable. With an iterator, once you've gone through one cycle of iteration, it's exhausted. It will not refresh. It will not work anymore. And I'll show you what I mean by this. So let's refer back again to the Python glossary. An iterator is an object representing a stream of data. Repeated calls the iterator's next method, or passing it to the built-in function next, returns successive items in the string. Okay, that's what I just said. When no more data are available, a stop iteration exception is raised in its stead. At this point, the iterator object is exhausted, and any further calls to its next object just raise stop iteration again. Okay, iterators are required to have an iter method that returns the iterator object itself. So every iterator is also an iterable and may be used in most places where other iterators are accepted. One notable exception is code which attempts multiple iteration passes. A container object such as a list produces a fresh new iterator every time you pass it to the iter function or use it in a loop. Attempting this with an iterator will just return the same exhausted empty iterator object, making it appear empty. Okay, let's actually go back to looking at some code and see that. Again, we're going to do the same thing that we did with our repeater, except I'm going to make this repeater be an iterator rather than an iterable. Okay? So what do I need to do that? Well, let's start with the easiest thing. Dunder iter needs to do what? I'll actually pause a second and somebody can just sort of throw that out real fast. return itself. Exactly. Okay, iter method's done. All right, now we here, let's see here, we have a, I need to get to my right spot and make sure I don't leave something out here. We need to do sort of the same stuff here, presumably. That is, we want to save value, right? We want to save the limit, so we'll know when to stop. Okay. There's one more thing that we need to do. We need to have a way of keeping track of how many times we have been called, right? It's the iterator's job to keep track of where we are in the iteration. So I'm going to call it count. So when we start, when I make a fresh object, it's going to start counting from 0. Okay, so that then only leaves us here with the guts of it. What does next do? Okay, well, the main thing we're doing is we're kind of keeping track of how many times we've been called, and we know that we have to stop when we get up to our limit. So we can do this with a fairly simple check here. We can say if self.count is less than self.limit, remember the semicolon there. See, I'm getting better. What are we going to do? Well, we need to do two things, right? We need to, first of all, increment the count so that the next pass will know we've already done something, right? And then the other thing we need to do is return self.value. We need to return our result. Yes, give the value. Exactly right. So we do that. Return itself. Okay, now that is partway through. If we reached the end of our iteration, which we'll just say else, because next is never going to go into negative territory, so we don't need to worry about that. We need to do the last thing, which is to signal that this iterator has done its job. Do that. Okay, so let's have a look here. Just a quick look and make sure we haven't done anything silly. Anybody sees anything silly, be sure to speak up or type up, whatever. Okay, set the value, set the limit in account. Next, the count is less than limit. So we go 0 up to limit. Do that, then we do that, then we do that. Okay, before we test this, Chuck's question, how about I write a method refresh to reset the count to 0? It is so tempting. And in fact, I used to have an implementation of the Fibonacci thing where I did that. It is legal. Python, as we say, is for consenting adults. You can do that. I would advise that you probably never do that because nobody expects iterators to behave that way. So you'll be having an object that behaves in a surprising way, and maybe it will surprise your friends and coworkers. Maybe, as I've said, one day it will surprise you. So that's why I wouldn't do it. But it is dead easy to do. You just add the method, reset self.count to 0, and you're off to the races. So you could do that. But let's see if we have any errors here. We don't. Okay, so that at least looks like a Python object. Let's see if we can use sequence semantics on it and use that to call the first item. Any takers? Is that a good idea, bad idea, work, error? Okay, we've got a nope. It's good enough for me. And nope, it is. Repeat iterator does not support indexing because we didn't add a get item. So, of course, it won't do that. We can say, the other thing we can do is we can check and see if it has a iter method. And of course, it does because, well, we just made that. It returns self, but it's got a iter method. So we're good there. Okay, now here's the next question. If we call next with it, does that work? And you don't need to say anything necessarily, but I want to pause a little bit so that you can think about that. Okay. It works. And we can do other silly things here. So this is just testing, this next bit of code is just testing to see if it's returning itself, right? So we called our initial object repeat iter. If we use the iter function to get an iterator from it and we put it in repeat iterator, and then let's see what that is. In theory, they should be the same object, and they are. Hello, Young Gun. So we're behaving according to spec. We got a iter method. It returns an iterator. The iterator is the object itself. We're all good. Then the next question is, well, and just for contrast, actually, I should say this. With our old repeat thing, if we did the same trick where we called iter on it, we would get two different objects. So I'll just hit that real fast. So repeater is one thing, and then we get an iterator. So that's why when you're working with an iterable, it behaves a little bit different than an iterator. Okay, now our last thing, we're going to stick it in a for loop. The comment there gives you a hint as to what's going to happen. We get 3 highs because all the way up here I called next on that object and I used up one of its iterations. Okay, I got the first value. And again, this is the thing with iterators. They only go through once. So when we got here, this is still the same object. We, behind the scenes, it gets iter called on it, which just returns the object itself. It's already been used for 1 with the next. So out of the 4 highs that we put into it to start with, we only get 3 back. Okay, so again, any questions? Whatever? Yes, it's only got the amount that you put in. It's not an infinite thing. It's whatever you get. So it's in at the beginning is what will come out, period. So again, this is pretty straightforward. We've got our next method, iter method, that returns itself, and it gets worn out after 1 pass. Now I do want to kind of go back and point out that here again, we have another kind of exception being raised to control looping. So in fact, if we were using an iterable, there would be 2 different exceptions that would be thrown to end the loop. If we're using an iterable, remember, index error on the iterable tells the iterator that the iterable is done. Then the iterator raises stop iteration. So in some cases in Python, in a for loop, you're going to have 2 exceptions thrown. Other cases, just 1. But you're always going to have exceptions thrown to end loops normally, to come to the end of an iteration process in Python. As I say, people coming from other languages find this just darned odd. Okay, now after that, let's see here, we've done that. Okay. Now, if we loop again, what happens? I'll pause for somebody to helpfully put in their best guess. Nothing. Exactly right. Because that iterator is used up, it immediately raises a stop iteration and nothing happens. Now, it's interesting to point out that things like database query sets and sometimes file objects are both implemented usually as iterators rather than iterables. So that's why you'll find people, maybe they make a database query call, they work through all of the records in the result, and then they want to go back and start over on the same object, except it looks like it's empty now. Because you can only iterate over iterables once. So things like a file object, database query sets, stuff like that. If you go back after the first time through, you got to get a fresh one. Otherwise, it's just going to look like you have no data. So yeah, you have to make a new object. Okay, so again, when we're doing this on the iterator rather than the iterable, like I say, basically the for loop process called iter on repeat iter, which returned itself. Then it did next, and it did next until it got a stop iteration, which meant it stopped. Okay, so that is how you can make a generator class. An iterator class, excuse me. But you never want to make a generator class, or almost never want to make an iterator class, because there's an easier way to do it. And that is you can use a generator. So we've got some time left. Let's see here. So this is just restating where we've been. Iteration is a protocol. We've got an iterable to iterate over, an iterator to keep track of what's next. Sometimes the iterator and the iterable can be the same object. If they do that, you're going to run out of stuff and it will not refresh. Okay, so there's a Fibonacci jailing here, but let's look at generators now real fast. Generators are a way to make iterators that is way easier than having to write your own class. So, for example, you're probably familiar with generator expressions. They use parentheses rather than the square brackets. And they do not, like a list comprehension, sort of create the whole list all at once in memory. Instead, they just give you the items as you need. So here, basically, I've done kind of the same thing with a generator expression as we did up above. So all I did was I'm going to print out yet a different greeting for every item in using a range of 5. And by the way, range is itself an iterator, so I am kind of cheating, but for the sake of illustration. So a few questions here. So we're going to do this, and I'm going to stop us right here and oops. Just so that we can make a point, and then I'll uncomment and we'll do some more. So there we go. So notice that when you do a generator expression, unlike a list comprehension, you go to print that out, we don't get hiya, 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 hiya. Instead, we get notice that we got a generator object. So the thing itself it behaves different than a list comprehension, which actually builds the list. Okay, and if we do that and we check to see if it has a dunder iter thing, yes, a generator object has a dunder iter method. Okay, that means that it's already both an iterator and an iterable, of course, we know that. Okay, the other thing is we want to see if it's got a next method, and it does. So this thing we get when we make a generator expression is an iterator. And we can, here, I'll go ahead and comment this out, and then we'll take it out of the for loop. which is all pretty straightforward. And then this works just fine. Now, normally, because it's just the way the idiom goes, normally you would take all of that generator expression and just pop it right in the for loop or wherever you were using it. The reason I broke it out and made it a separate object was to illustrate that the thing that gets created behind the scenes is in fact a specific type of object, and that object is an iterator. So that's why I split it out separately. Normally you wouldn't do that. Okay, and like I say, we can do all sorts of things with this. We can do things like where we can do that, and basically after we exhaust it, if we call next on it again, we get stop iteration. That's cool. All right, there's one last distinction between list comprehensions and list generators. It's kind of an interesting parlor trick. So here I've got I start with a list that contains 1, 2, 3, 4. Here I make a generator using a generator expression, right? Okay, here I do a list comprehension. Okay, now let's look at the first case here. This is a silly example. I do not recognize doing that code. Now, yes, Chuck, both of these will work. Okay, but there's kind of a distinction because you notice after I print, I append, if I have less than 10 items, I just append the current item back onto my list. Okay, I do it in both places. It's the same thing. And there's a reason why I put I use the less than 10 rather than just going on forever, because that's what will happen. So these will both work. Okay, one of them is going to print, well, let's put it this way. If we're down on the list comprehension, let's look at this one down here. How many things is that going to print? Well, one of them is going to print 1, 2, 3, 4. Okay, now let's look up here. Now this one, how many is it going to print? Yes, you're asking the right question. Does the generator get updated on the fly? Well, let's give it a try and see. So I'm going to go down. I'm going to do the list comprehension one first because that's sort of the base case. So 1, 2, 3, 4. As it went through, it added another 1, 2, 3, 4 onto the list here, but then it ended. And the fact that it was adding these on after the fact did not seem to affect the iteration, right? So it added them because we told it to, but it really only ran 4 times. Okay? Now, I wouldn't be doing this if something silly didn't happen. So it's the same thing. I'm going through. I've created this list gen object. So I created the object here. The iter gets called on it, which calls under iter, which returns the object itself. So it's going to count through the stuff that it's got. And it's going to print it out and then add one onto it if it's less than 10. Okay, so here we go. Now you'll see why I put the less than 10 there. because it just keeps on going. As it got here, we added one, so it goes up here and whatever, and it just keeps on working through what was in the list. So this doesn't get all evaluated when we create the list, when we create the object, I mean. That expression gets evaluated every time you call next on it, in effect. So that means you get very different behavior, and if you weren't ready for that, very surprising behavior. Now, in general, it's not a great idea to go mutating objects in a loop if they're part of what you're looping on. In general, this is a bad idea. And this is kind of a reason why it's a bad idea, because you can get some weird things here. So in terms of the question, is this a pure don't try this at home? I think it falls into one of those categories where if you know exactly why you want to do this and you can explain to other people and defend it, then maybe you can use it. In all other cases, don't try this at home. It would have to be a very, very specific use case before this would be, because it's going to fool the people around you and possibly yourself. So yeah, it's just in general, it's not a good idea. If people on my team were to write this code for, code review, it would not survive. I mean, not even me. Nobody else on my team would let this through, I don't think. Unless there was just an overwhelming reason for it. So no, I wouldn't recommend doing it. But it does illustrate the difference of, with a list comprehension, the object gets made at the time of the comprehension. With a generator, even though the format is the same, it's just changing to a slightly different thing. It makes a huge difference. And Chuck, I think that's an interesting point. It's possible if you were doing some sort of data handling from a source and you wanted to respond to a change that way, there might be a defense for that. I would almost argue, my personal taste would be to argue against using a generator expression and maybe use a generator function then. Something where it's a little bit easier to do. And this is the last thing I have to show you, which is exactly the same sort of thing, except now done as a generator function. So generator expressions are really kind of syntactic sugar for a generator function. So generator functions behave exactly the same way. They just have a fuller, more function-like expression, so you can do more with them. Generator expressions needing to be expressions are a little bit restricted. The walrus operator may help some, but you could get some ugly expressions if you tried to cram everything into a generator expression. So generator functions are usually better if you have anything more complicated. And this is kind of the same thing. So this is a generator function here. And the thing that makes it a generator function is the fact that it uses yield rather than return. Okay, there is, of course, an implicit return after this for loop ends and the whole function is done. But while it's actually doing its thing, returning values, you use yield. And again here, let me comment some things out because I want to, we've been at this for a while, so I'm kind of moving towards wrapping it up, but I want to show you a few things about this. So we're going to just do this. So I'm going to make a repeat generator here. And you'll notice in printing it out, it's just a generator object. So that means that if we were to check, it would have a dunder next. It'll have a dunder iter. It's going to have the same sort of stuff. It's going to be the same kind of object as the one we made up here. Okay. It's just rather than coming from gen expr, it's going to come from repeat gen, the function. So it's a function, but it's the same thing. And again, I sort of cheated and used another generator, another iterator here to out rather than doing manually counting up. But basically, we're just for each I, we're going to return the value so that we get the right number of times. So, if we do this, it's exactly the same behavior. And again, we could, here I'm trying to emphasize the same thing. When we call this function, we called it here. When we do that, we get an iterator object. So it's kind of hard to wrap your mind around generator functions if you think somehow they're being called over and over and over again as you use them in a loop. They're not. The object that they've created is being called over and over again because it's an iterator, and that's its job, is to keep track of repetitions. So, it would be perfectly legal for me to do this. You've seen that a lot. Well, okay, so I don't have value. I need to do that, so I would need to actually do this. I'm sorry. Let's get rid of that, and I need to do this. Sorry. There. Perfectly legal to do that. But I wanted to make the point that this is actually kind of a two-step process when I'm calling repeat gen directly. So could you say they are a factory function for generators? Yeah, definitely. They produce those objects. And that, I think, makes them a lot easier for people to understand than if they somehow think that you've got this magic function being called that then behaves in a way that nothing else does. Because remember, from call to call, from iteration to iteration, it remembers where it is in that loop. It keeps all of that local state. And Python functions, regular functions, don't do that. So that's why I think it's always good to make that point. And that also means then that you can nest them one inside the other because basically this one gives us one iterator and this call gives us a separate iterator. So when we run them, they're totally fine. They can kind of go back and forth, hi, hello, have different counters. So sometimes you nest generators. There are various reasons why you might want to nest generators. And they're fine. But again, it's because we're actually using two different iterator objects here, not the same function that's getting fired over and over again. So that's the idea. And again, we can go and do other exercises with that. But this is the basic idea. And that's why, I just find this kind of a fascinating encapsulation of what kind of being Pythonic and how Python thinks about things works. I mean, this whole protocol has been built up over, 25 years or something like that. But it really has a lot of layers to it that illustrate how Python behaves and how you might think about things. And of course, when you get into doing things like generators, and then that leads to async I/O and various other things that are fairly advanced. Without having a basic understanding of this stuff, you tend to get really puzzled really fast. So, and I've seen that happen more than once. So that is pretty much what I wanted to talk about today, and that's about the same amount of time. We're a little over an hour, but that's about as much as I can talk. So again, you can do a Fibonacci generator if you want. Looking for any particular links, like I say, you can go grab this notebook off of the GitHub location, and you can get all of these references, but they're mainly the Python documentation. So you can find those, and of course, if you've been watching on Twitter, they've been doing all the translation of Python documentation into Spanish. So you can probably even get some of these in Spanish soon. I think they've done the tutorial, so that's there. And then again, the Dave Beasley's talk about the history of the protocol is fascinating stuff. It talks a little bit about what we've talked about, but much more in general about kind of the prehistory, the archaeology of you, if you will. So definitely good. Um, and like I say, it's all pretty much the same stuff. Um, I guess I can also announce if you're looking forward to EuroPython, I am too. I'm going to be one of the keynotes at the EuroPython online version. That was just decided this week. So that's another bit of news I've got, and that's about it. So are there any final questions or anything that anybody wants to add? Again, I've got a list of resources that are down below in the panel below this video on Twitch. You get the link to the slides and all of that stuff there. And you know, if you've got any particular suggestions, there is a little suggestion thing there and whatnot. And otherwise, I I'm not sure if I'll be back next week or if I'm going to be taking a week off because I need to prepare for another online thing that I'm doing the following week. But I've got a handful more of these things to do, so this won't be the last one anyway. And stay tuned. I'll be putting it out on Twitter and I'll be updating it here if I do write one next week or decide I don't have time. But we'll have a few more. And again, it was a pleasure to have you. Some of you back several times, Matteo, and nice to see you, Susanna, and various other people that are here. So I'm going to switch over to my ending stream here. Yeah, we will see you at another time then. Everybody take care, stay safe, deal with the situation as best you can. We'll see you later.